Hello everyone, welcome back to the second video on the concept of divisibility rule under the topic number system. So in the first video we discussed some basic principles of the divisibility rule, that is we use the concept that dividend is equal to divisor multiplied by quotient plus the remainder, and based upon that we solve questions and we figure out the values whatever was asked in the question, right? Which is like one of the most important aspect if you're appearing for GMAT or GRE. So this divisibility rule is usually asked in the exams. So the main idea is you need to understand how can you convert the words or the statements into a mathematical equation or expression, and thereby how can you solve it. So if this is the first video that you're watching on divisibility rule, so please go through the first video because that consists of important concept and an important type of questions. Okay, so without wasting your time further, let's move on to the next thing, that is more on the divisibility rule. Okay, so let's say you have a statement that n square is completely divisible by 4 where n is a natural number. Okay, so let me remove this first. Let me define the condition that n is a natural number. So n square is divisible by 4, find the smallest possible value of n. N square is divisible by 4, find the smallest possible value of n. Or for example, n square is divisible by 6, find the smallest possible value of n. Or for example, n square is divisible by 12, find the smallest possible value of n. N square divisible by 18, find the smallest possible value of n. N cube divisible by 48, find the smallest possible value of n. So how do you figure that out? So for example, when you do n square is completely divisible by 4, that means I can rewrite this as n into n is completely divisible by 2 into 2. When you prime factorize 4, it will come out to be 2 into 2. When you prime factorize n square, it will come out to be n into n, because n is a natural number, right? Now, if I want to find out the smallest possible value of n, I have two 2's in the denominator. So what I'll do is, I'll give this 1 2 to this n, so that this n becomes 2, and automatically the other 2 will go to the other n, so that this automatically becomes 2. Or in short, you can simply say that the smallest possible value of n which will satisfy this is equal to 2. When you go for n square divided by 6, then I can rewrite this as n into n divided by 2 into 3. Right, I have prime factorized 6 and I have also written n square as n into n. Now, what I'll be doing is, I'll give this 1 2 to this n, thereby making this n is equal to 2. Right? Now the problem is, if I give this 3 to the other n, this will simply become n is equal to 3, which is quite not possible, because at the same point of time, how is it possible for n to be 2 as well as 3? Right? It's not possible. So what do we do in this case? So I have given this 2 to this n, so this first n automatically became 2. I don't have any other 2 which I can give to the other n. So what will happen, this n will automatically take up a value of 2, because I cannot take n to be 2 different values, it's not possible. Now this 3 which is left, you give it either to this n, making this n is 2 into 3, so the other n will automatically become 2 into 3. Or if you would have given this 3 to the other n, let's suppose you would have given this 3 to the other n, then this n would have been 2 into 3, so the other n will automatically take up one more 3, which means the minimum possible value of n will simply be equal to 6. It will simply be equal to 6. If you go for n square by 12, so that is n into n divided by 2 into 2 into 3. Okay, now I have two 2's and I have two n's, so I'll give 1 2 to one n and I'll give the other 2 to the other n. As simple as that. So both n's will become 2. right? I'm left with 3. Now this 3 cannot be divided further into 2 parts so that both the parts are natural numbers. So whatever cannot be divided, I hope by now you must have figured it out. Whatever cannot be divided, you will simply give it to both the numbers. You will give it to both the n's. So this 3 will be part of this n and this 3 will also be part of this n. As simple as that. Okay. Let's say if you have n square divided by 18. So n into n divided by 2 into 3 into 3. So I have 2 3's, 2 n's. I'll give one 3 to this n, another 3 to this n. So both of them will become 3 and 3. Now I have a lone 2. I cannot give it to one of the n's. So I'll give this to both the n's. This as well as this. So both of them will become 3 into 2 and 3 into 2. Which will simply give you n is equal to 6. Okay? Okay. Last one is n cube by 48. We'll use the same principle. So n into n into n. Now 48 is 16 into 3. 16 is 2 times 4 into 3. Now, is there anything which is coming thrice? Yes. 2's are coming 4 times, but they are coming thrice. I'll give this 1 2 to one n, another 2 to the another n, another 2 to the another n. I'm still left with 2 into 3, which is 6, right? Now this 6 I cannot divide into 3 equal parts, right? Because the product of 3 parts, 3 natural numbers is never equal to 6. Some can be equal to 6, but product can't be. So n's will become 2 2 2, and each of the n's will be multiplied by 6, because this 6 cannot be divided into 3 equal parts so that the product of those 3 parts is equal to 6. So multiply these 2 by 6, so you will get n is equal to 12. Okay. All right. So let's take up a question. So it says that m is a positive integer and m square is divisible by both 8 and 12, and find the minimum value of m. So we can use the concept that we just discussed in this question. So m is a positive integer, m square is divisible by both 8 and 12. So m square is divisible, which means m into m is divisible by 2 into 2 into 2, and m into m is divisible by 2 into 2 into 3. Right? You need to find the minimum possible value of m. So for the first one, first 2 will go to the first m, another 2 will go to the another m. The lone 2 is left, so I'll have to give it to both the m's. The minimum possible value is 4. Minimum possible value is 4. Second one, I have two 2's. So one 2 will go to the one m, another 2 will go to the another m. Now I have a lone 3, so I have to give it to both the m's. The minimum possible value of m is simply equal to 6. Now I need a m which is a multiple of 4 as well as that of 6. So what I'll do is I'll simply calculate LCM of 4 and 6, which is simply equal to 12. So the minimum possible value of m is simply equal to 12. That's it. Alright, pause the video and try this question. So if a positive integer n is divisible by both 4 and 21, then n must be divisible by which of the following? So if n is divisible by 4, then n must be in the form of some number multiplied by 4, or you can say that it will be in the form of some number multiplied by 2 square. Right? Similarly, when n is divisible by 21, then n will be in the form of some number multiplied by 21, or you can write some number multiplied by 3 into 7. So one thing is for sure, that is no matter what happens, n is definitely a multiple of 2 square into 3 into 7. Sorry, my bad. N is a multiple of 2 square into 3 into 7. Right? Then n must be divisible by which of the following? So 8 is 2 cube. I don't have 2 cube. I only have 2 square, because when I'll write n will simply become 2 square into 3 into 7 divided by all these options A, B, C, D, E. Now when I'll divide this by 2 cube, I'll still be left with 1, 2 in the denominator, right? I'll have 3 into 7, 21 divided by 2. So this is not divisible by 2 cube. It's not divisible by 8. It's not possible. This goes out. What about 101? 101 is a prime, right? So I can't factorize 101 further, so it's not divisible. If I talk about 18, 18 is basically 3 square into 2. Now 2 will be cancelled from 2 square, but I have a 3 square, so I'll be left with 1 3 in the denominator. I will be left with 1 3 in the denominator. So again, it's not divisible. What about 28? 28 will give me 2 square into 4. So 2 square is divisible by 2 square into 7, my bad. It is 7, 4 into 7. So I can cancel this 2 square from this 2 square, and I can cancel this 7 from this 7. So it is definitely divisible by 28. That's for sure. Next is 48. 48 is how much? 2 to the power 4 into 3. So I can cancel this 3 from the 3 in the numerator, but I can't cancel this 2 to the power 4, which means I'll be left with 1 2 square in the denominator. So n is not divisible by 48 also, which means n is definitely divisible by only one number, which is equal to 28. Alright. Okay, let's move on. Try this question number 6, please. Alright, let's see what we can do with this one. When a positive integer x is divided by 9, the remainder is 5. So when x is divided by 9, the remainder is 5, which means you can simply say that x is equal to 9p plus 5. X is equal to 9p plus 5. P is acting as a quotient here, okay? What is the remainder when 3x is divided by 9? So you want 3x. So 3x is 3 times 9p plus 5. This is divided by 9. Or let's not. So this will basically be equal to 27p plus 15. So we need to find the remainder when 27p plus 15 is divided by 9. Now from 27p divided by 9, you will not get any remainder, right? Because 27 is a multiple of 9, so the remainder will be 0. The only remainder that you can get is from 15 by 9. When you do 15 by 9, your remainder will simply be 6. Your remainder will simply be 6. That's the answer that you're looking for. Alright. Pause the video and try this question, please. Okay, let's see what we can do with this one. X, y, a, b are positive integers. When x is divided by y, the remainder is 6. Okay. When a is divided by b, the remainder is 9. Which of the following values is not possible for y plus b? Okay. So if x is divided by y, remainder is 6, which means I can write x will be equal to y times the quotient plus 6. And when a is divided by b, remainder is 9. That means I can say a will be equal to b times the quotient plus 9. Okay. Now, when you talk about this concept that dividend is equal to divisor multiplied by quotient plus remainder, right? In that case, always remember that divisor is always greater than quotient. For example, let's suppose I have a number 13 and I divided by 2, okay? Sorry, my bad, it's not quotient, it's remainder. Sorry. This is remainder. Let's suppose I have a number 13 and I divided by 2. So you don't write, okay, 2 into 5 will give you 10, the remainder will be 3. No, this is incorrect. If you're dividing 13 by 2, you don't say, okay, it will go 5 times, so 2 into 5 is 10, so we'll be having a remainder of 3. No, it would be incorrect. Why? Because your remainder, which is 3 in this case, cannot be greater than your divisor, which is 2 in this case. It cannot be greater than the divisor, which is 2 in this case. So you say that, okay, we'll be dividing 13 by 2, so it will be 6 times 12 and my remainder will be equal to 1. Remainder is always less than the divisor. Remainder is always less than the divisor. Which means you can say that no matter what happens, from the first equation you can say that y will be greater than or equal to 7 or b will be greater than or equal to 10. Which means y plus b will be greater than equal to 70. Greater than equal to 70. Which means 24 is possible, 21 is possible, 20 is possible, 17 is possible. 15 here is not a possible value of y plus b. 15 here is not a possible value of y plus b. This is the kind of question which they can ask you in GMAT also. Typically it's very easy, but again it's conceptual. That's the whole point, right? Your concepts need to be crystal clear. Alright, let's move on. If a positive integer n is divided by 5, the remainder is 3, find the sum of all possible unit digits of n. So pause the video and please try this question. Okay, let's see what we can do with this one. So when a positive integer n is divided by 5, the remainder is 3, which means I can say n will be equal to 5 times an integer value plus 3, right? Again, integer here stands for quotient, okay? Find the sum of all possible unit digits of n. Okay, so let's do one thing. Let's start with I is equal to 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7. So I have taken up 8 values of quotient. Let's see whether we'll be getting a cyclicity or no. Because if we do get, then don't have to worry about it. If we don't, then it becomes a problem for us. So when I'll put I is equal to 0, the value of n will simply be 3. When I'll put I is equal to 1, it will become 8. When I'll put I is equal to 2, it will be again 13. Then it will be 18. Then it will be 23. Then it will be 28. Then it will be 33, and then it will be 38. There are only 2 possible values at the unit digit, that is 3 and 8. Nothing else is happening. Hence, the sum of all possible values of unit digit of n is simply equal to 11, and that's the answer. It is simply equal to 11, and that's the answer. Now what could have been the other way around? Let's suppose you say, no, we are not satisfied with this approach, we want a proper approach, we want to prove this. So fine, let's do that. Now when you talk about positive integer, there are only 2 types of positive integers. One is odd, one is even. One is odd, one is even. Even integer can always written in the form of 2n, and odd can always written in the form of 2n plus 1. Or you can write 2n minus 1 also, that's completely your call. If I start with even integer, then the value of n, okay, if I start with even integer, when I is even, then the value of n is basically 10i plus 3, right? Then it will be 10i plus 3, because it will be 2 times of a number. So 2 into 5 will give you 10. So 10 plus 3 will always give you a unit digit of 3, because this I you will be replacing by integers. It will be replaced by integer values. Like you can replace I by 1, 2, 3, 4, 5, 6. So number will become 13, 23, 33, 43, 53 and so on and so forth. If you take I to be odd, then n will be equal to 10i plus 5 plus 3, which is 10i plus 8, right? When you replace I by 2n plus 1, 5 into 2n is 10n, 10n plus 5 plus 3 is 10n plus 8. So replace n I by 1, 2, 3, 4, 5, 6, even if you replace it by 0, doesn't matter. You will again get 18, 28, 38, 48, 58. So in this case, your unit digit will always be 8. So there are only 2 unit digits possible. One is 3, one is 8. If we use our logic, right? So hence the answer is 11. 3 plus 8, that's 11. Alright, let's try the last question for this concept. Pause the video and give this one a try, please. Alright, let's see what we can do with this one. N is a positive integer and n square is divisible by 12, then which of the following must be an integer? So n square is divisible by 12, which means n into n is divisible by 2 into 2 into 3. 2 2's, so 1 2 will go to one n, another 2 will go to another n. 3 is a lone number, so it will go to both the n's. So n will be a multiple of 6. Smallest possible value of n is 6, but n will simply be a multiple of 6. Or you can write n in the form of 6i, where I is an integer. Which of the following must be an integer? First one is 6n by 7. 6n by 7 is 6 into 6 into integer by 7. Now 6 into 6 is 36, 36 into integer by 7. Now it's not necessary for integer to be a multiple of 7, right? That integer can be 2, 3, 4, 5, 6, 7 also. So you have 36 into some integer value divided by 7. So this is not necessarily an integer value. If I is a multiple of 7, then it will be an integer value, otherwise it will not be. So it goes out. And you do 13 by n. That is 13 divided by 6 into an integer value. So no matter what value of I you take, whether you take 1, 2, 3, 4, 5, 6, and even if you take it to be 13, this will never be an integer. This will never be an integer. So this also goes out. Then you do 48 by n squared. So when you do 48 by n squared, so that is 48 into 36 into I square. Even if you simplify this, that will become 4 by 3i square. Now, no matter what value of I you take, 4 by 3i square, I being an integer will never give you an integer value. No matter what value of I you take, I being an integer, 4 by 3i square will never give you an integer value. So this also goes out. Last one is n square plus n cube by 36. So n square is 6i square. This is 6i cube divided by 36, so that is 36I square plus 216I cube divided by 36. Right, so this will basically become 36I square by 36 plus 216I cube by 36. This goes out, this goes out, this becomes I square. 36 times 6 is 216, so this is 6I cube. Now I is an integer, so I square is an integer. I cube will also be an integer. So 6 into an integer will also give you an integer. So this number here will definitely be an integer. Hence your answer is option number 4. Okay. So these two videos are like more than sufficient as far as our concept on divisibility is concerned. Alright. So thank you so much for watching this video. If you like the video, please subscribe to the channel for more videos and exam related content on GMAT, GRE and SAT preparation. If you're looking for personalized classes, then you can always connect with us. Okay, you can text me or you can mail me also. Alright. Alright guys, thank you so much. Keep watching and keep learning.